All right, happy post-lunch coma. Thank you guys for sticking in. I'm going to go ahead and get started here. So once again, my name is Stuart McClure. I've spent the last 35 years really attacking code, but I started my career in writing code and building code, probably the first third of my career. And of course, back then it was really simple. I mean, you either knew it or you didn't, and you had to figure it out quick with very few resources. So we are today in a totally different revolution. And to tell you my journey real quickly, so started in cybersecurity, and I've hacked just about any device known to man, anything that's crawled, walked, or run. And I've spent a lot of it on stages just like this, doing live demonstrations of hacks. Now, I won't do that to you guys. I don't have as much time as I'd like. But typically, I'll actually ask for a volunteer, have them come up on board, and I would hack their device, given their approval, of course, right on stage. Now, don't worry, y'all look nervous like I'm going to do that. Don't worry. But what I do want to talk about is how every single one of those attacks, every single hack that I've ever performed, all come down to code. It begins and it ends with code. And that's where my journey really came into with Qwiet AI. So Qwiet used to be a company called Shift Left. If you've heard of that concept, right? It's the idea that we need to take cyber and security as far left into the cycle as we possibly can, because it's the easiest to fix there. It's much harder to fix at the far right when you're breaking into it on stage and figuring out which line of code is at problem. So we are masters, if you will, of finding those vulnerabilities inside a code. And what happened when I started to work with Shift Left is I realized, wow, we could apply AI specifically into Qwiet and how they evaluate code, which is truly unique in the industry. So all of you are now probably neck deep in trying to get some sort of code generation LLM to work for you. And if you haven't yet, you probably will shortly after the show. This is not going to go away anytime soon. We've now opened this Pandora's box. The genie's out of the bottle. We're not going to stop doing this. So what I'm trying to make sure I educate as best I can is to show you where the limits are and where the blind spots are so that you can be aware when you engage these generative machines, you know where to look for the common flaws and problems that occur. So this is just simple Copilot, but you probably all have tried to engage with some sort of other generative model out there. And what you're finding is, yeah, you can code a lot faster, and a lot of people are writing a lot more code. But what that tells me is all of those generative machine learning models out there are absolutely built on insecure code. So as you ask the models to generate certain types of code, you're going to get the same vulnerabilities that were created in the code originally when the models were built, when those transforms were built. So it's really important to know and just remind yourself, the only thing you're getting out of a generative model is what was put in. And what was put in was inherently insecure code. So I'm going to talk a little bit about that. Now, you've probably seen a few of these models, maybe not all of them. You should definitely explore all the code-centric models that are out there today. Some are better at some languages, others are better at others. But none of them, not a single one of these, have taken security at the very beginning and ensured that the data that it's building the model on is actually preventative of cyber attack. So what you're doing is you're carrying all three categories of attacks into the code that you're generating in the model. So the three categories of attacks, first is execution-based attacks. These are things like buffer overflows. You probably hear about this. controlling the variables and what happens and taking attacker input, making sure that you control that variable and that input to not allow it to do anything that the attacker wanted. That's the first category. The second is identity-based attacks. These are attacks that leverage others' identity. It's stealing an API key, it's stealing a token, it's stealing your username, password, it's brute forcing it, whatever. And then third is denial of service attacks. And these are just taking advantage of normal everyday functions inside of listening services or apps and exploiting them far beyond what they were ever expecting to bring them down. Now, there is one other class of attack that we see primarily in apps, software applications. It sort of covers all three. It's what we call business logic flaws. And what we're going to talk about with business logic flaws is a whole nother sort of realm of what not to do with code. Now, if you haven't, start looking into who's tracking on security in the code generation models that we're getting right now, because there are a select few early adventurers that are taking code, really going line by line to see where the vulnerabilities are in the code, and then just going back and asking things like ChatGPT or GPT-4 or you name it, hey, this is not secure, how can I make it secure? And it does not do it at all. Like, there are very, very few recommendations that are positive for you to contribute back into your code from a secure perspective. So take a look at some of the folks out there, like Low Level Learning. For example, Decode Bytes has a great article. Please don't use GPT for security guidance. I think that's more of a headline. I would say start with GPT, asking it for security guidance, but please do not use that as the definitive source. What you'll find is it might get you to that first step, but you're going to struggle to get second, third, and fourth iteration in for code security. So the attack landscape of code, if you've never seen or sort of delved into it, this is an easy sort of slide to understand. On the left is the data in to a model and the model itself. So are you polluting that model with data that is uncontrolled, that perhaps is controlled by an adversary or modifiable by an adversary? You have to, every single time you're dealing with some sort of LLM, generative, or any model for that matter, predictive or language learning, whatever, you really want to understand where is that coming from? Can we manipulate? I don't know if anybody goes to Vegas and watches, goes to Black Hat or DEF CON, but DEF CON is a famous hacker conference, and last year they pen tested ChatGPT and got their own instance of it and got it to actually cough up the credentials of the box itself because it had been trained on all of the materials on the system itself. And it did it by what they called mean girling it, which is telling them that someone was going to beat them up or hurt them if they didn't disclose those credentials. So the data, where how you train your models and how you implement those models is really important from a cybersecurity perspective, because me as an adversary can get into any of those, potentially. But then on the right side, it really is the outward-facing expressions of the models. So once you implement a model or once you start to generate code from that model, now you're really talking about the functions, the variable handlings, the library inclusions, things of that nature that need to be regularly tuned and evaluated for those security flaws. And it's so simple to miss some of the easiest of vulnerabilities, especially when you rely on automatic code generation systems. And what we're finding is a number of vendors are saying that they can do it all. They can allow you to create code, they can allow you to find the vulnerabilities, and they can allow you to fix. And I think that's a bit of a recipe for disaster right now. I really do recommend that we all take a look at each one of those elements and bring in the tools that are best in that space to deliver on the best results for each of these. So from code generation, vulnerability discovery, as well as fixing. because each one of these is a very specialized field that a lot of people try to get into without much knowledge and firsthand experience. All right, so what we really need to build, I think, into AppSec is AI. I really believe it is the only way that we can get to a place where we can auto-generate secure code and make it stand the test of time. But you have to think about whenever you build code and you're getting code from a model, you have to think of it in these 5 factors, really. So there are known vulnerabilities that everybody knows about, right? There's a CVE or a CWE that's associated with a vulnerability, and you want to find those for sure. But you need to find the unknown unknowns. These are the vulnerabilities that have yet to be found. They've yet to be discovered. That even a full class of vulnerability, a brand new one, could be coming out anytime. And you need to find these vulnerabilities before the adversaries do. So having a model and a predictive model to find the unknown unknowns in your code. Then you need to think about business logic flaws. Now, this is an easy one. It seems complex because you're actually looking for the logic of your application and then finding some flaw in the logic of it. But there are simple examples of it. A great one is a hacker went into a McDonald's that had a kiosk. The software built on the kiosk allowed you to do maximum numbers of patties and cheese slices and lettuce toppings. Well, McDonald's had marketed that if you ordered from the kiosk and the order wasn't ready in 10 minutes, it was free. So you can see how a hacker would have gone in and said, well, we're just maximizing everything. And of course, there was no way they could deliver that order in 10 minutes. So he got a $300 order for free. And it went viral on YouTube and it was fun to watch. But at the end of the day, that's a great example of a business logic flaw. Like, who as a developer thought, well, geez, these poor servers and cooks are never going to be able to match this time that the marketing team is saying that they can do. So there's that disconnect that an adversary or bad guy can take full advantage of. And there's far more complex ones, but that's just a simple one. But there's also specific rules within your company, within your teams, about how to address security vulnerabilities that may or may not be consistent with how these LLMs are getting built. So that distinction is really important, and to call out those specifics and ensure that you can train your own LLM on those specific fixes. It's one of the most important parts. And then lastly is the concept of auto-fixing. So we're building a lot of code, we're creating a lot of software around it, but we're not auto-fixing this stuff. And I do believe there's a space and a place for us to insert ourselves into that code generation process to automatically fix based on the elements before it. So the coding standards inside your organization or team, the business logic flaws that are common inside of these applications, and then known and unknown vulnerabilities. So whenever we build cybersecurity inside a code, we think of it as a risk framework. You can never get rid of 100% of defects. You can never get rid of 100% of security flaws. So the goal is to find out, where is your measure of tolerance? How much are you willing to put up with? How much risk? Once that is defined by your team or your company, then a lot of this can work itself out. We can do a risk assessment based on that risk model. We can do a threat modeling. Threat modeling is where we come in and take a look at all of your applications, and we give you a scope, a threat-centric view scope of your apps. And we try to get you to design the application from the very beginning based on those threat modeling exercises. But at the end of the day, risk governance might be all that you can do, which is, hey, the powers that be in your organizations are telling you got to be NIST compliant, or you got to be something compliant. You can just put the context of security inside of that compliance mandate and deliver on code to that. And then lastly, of course, vulnerability testing using AI. I do believe this is going to be commonplace. Today, it's quite unique and not many people are doing it. But that's where Qwiet AI really comes and shines. So the legacy technique for finding flaws and fixing them is really, really slow. It's really high false positive rate. I don't know how many of you have been victimized by a cybersecurity code scanning tool, and I apologize for that. But you'll often, as developers, get exhausted by all of these findings, most of which are completely phantom. They don't really exist. They look like they exist. Well, look, it's all fancy writing, and oh yeah, this looks really bad, parade of horribles of what's going to happen. But in the end of the day, it's just, let's say, a finding of a library that you instantiate, but you never call the vulnerable function. So it's not reachable. So what do you care? This is where you have to have the context around the finding. And really no one in the industry does this well. We thrive at this. You have to create that why. Why is this a vulnerability? Developers are not trained on security, so they're not going to really, you're going to see it right away. But walking them through not just why the context, but why it's at a real risk to the organization, I think is really important. And of course, the traditional method, the legacy method, is you can only find what you know about today. So if you know that there's a type of vulnerability like a SQL injection or a buffer overflow, well then sure, you can go look in code for that. But what about the vulnerability that is not mapped out yet, discovered, mapped out? So that's where really AI is going to come into play. So we at Qwiet have built predictive models on detecting known and unknown vulnerabilities in code today. And we've had that out for about a year now. And we're going to continue to expand more and more. And our target is fixed on providing an auto-fix, auto-suggest capability inside of our product. So as a developer, and you're in your CI and you see the vulnerabilities, you have the option of a fix recommendation with the natural button of, yep, let's fix it. So this will allow you to get the context of the vulnerability, but also be able to detect those unknown vulnerabilities as well. So just to finish out, you really, I think, would go well to help the organization as they instantiate and use these models to extend these models, build it more specifically to you, to your code, to your coding standards, to how you go about and run code. I don't believe any model will rule them all when it comes to this. There's too much specific nuance to how you build. But have a system in place and a technology that can go with you. And securing through some sort of auto-suggest, auto-fix function is inevitable. We're getting to a place where we could one day be hands-free on the fixing. So code generation and code fixing happens at the same time. So you get your company-specific coding standards implemented inside of any code generation machine. So with that, I'm super excited about AI in AppSec, and I believe when you think about all the vulnerabilities that occur, 100% come from code. If we can predict and prevent security flaws inside of code, you can drop the mic and we can move on, right? We don't have to be burdened with cybersecurity. It can be a natural feature of what we deliver on. So in a nutshell, there's so much upside for AI. We are in the very early stages of code security and implementing this properly and effectively for you as developers and as organizations that develop. But keep an eye on us at Qwiet AI. You can absolutely get a free account, get on there, play with it, take a look at some of the detection models that we have for Java and C# and others. And I'd love to get any feedback that you have. So please follow up with me. And thanks again for your time.